So the next lesson is laws of motion. Okay. So the basic thing first what we should learn is what is the meaning of force. So the basic term of force which we would have come across in 8th, 9th and 10th class. Okay. So force is nothing but it's either push or pull. Yes or no? Either if we push or either if we pull, we will call it that as a force. Okay. So first topic, force. The first topic is force. Okay. Right on the first topic, first point. So force is nothing but either push or pull. Either push or pull. So obviously we know that like push is nothing but the force is away from the body, right now. Like we are applying the force and it will go away from us, and pull is nothing but the force will come towards us. Okay. And the second point is, what is the SI unit of force? Newton. In other word, kg meter per second square. Newton or kg meter per second square, either any one. So what will be the dimensional formula? You have studied dimensional formula, no? M power 1 L power. So this is the dimensional formula of the force. So force is a vector or scalar quantity? Okay. Force is a vector quantity. So force is nothing but it's directly proportional to the mass and the acceleration, no? What about acceleration? Velocity by time, no? What about velocity? Displacement by time. What about displacement? It's a vector or scalar? It's a vector quantity. So I need a clarification from your side. Is force only applied on the living organism or it is applied on non-living organism also? Like if we are applying force, okay, we will say that either it's a push or pull. Okay, we are not applying any force on the objects. Will there be any force on the non-living organisms? Yes. What kind of forces? Gravitational force, frictional force. Tell. The normal force. Yes or no? What is the normal force? It's a perpendicular force, right? Okay. So obviously like forces are exerts in the non-living organisms also. Okay. Write down the types of force. The types of force. So first one is a gravitational force. Gravitational force. Second one is electromagnetic force. Third one is nuclear force. And fourth one is a weak force. Gravitational force, electromagnetic force, nuclear force, weak force. Okay. We'll talk about each force now. Write down note point. Note point. So force is an interaction between any two object. Any two object. Second point, if more than one force is acting, we can find the resultant force, by using law of vector addition. Okay, write on the first topic, gravitational force. See, like 4 types we have seen, no? Gravitational, electromagnetic, nuclear and weak force. We are going to mainly concentrate on the second point, electromagnetic force. Okay, gravitational force, well, like we will see a detailed in the gravitation lesson. Okay, and remaining nuclear and weak force also in second year we will see. Okay, and the first point under gravitational force, formula for that is F is equals to G m1 m2 by r square, or capital M small m by r square, whatever it is, capital M small m by r square. Where G is the gravitational constant. So G is equals to 6.7 into 10 power minus 11. 6.7 into 10 power minus 11. So what will be the unit of the gravitational constant? Keep gravitational constant one side and send the remaining thing to the other side. So F r square divided by m into m will be equals to G. This is Newton, this is meter square per kg square. This is my gravitational constant unit. Okay. So r is nothing but it's the radius of the earth, which is nothing but 6400 kilometer, 6400 kilometer, 6400 kilometer. And mass, capital M is the mass of the earth. Approximately it is 6 into 10 power 24 kg. 6 into 10 power 24 kg. R is equals to 6400 km, and capital M is equals to 6 into 10 power 24 kg. It's everything, it's approximate. Okay. So that's the basic thing about the gravitational force. Okay. Second one, electromagnetic force. So here the formula which we are going to see is F is equals to 1 by 4 pi epsilon naught q1 q2 by r square. And one more point is there for gravitational. So gravitational force is always attractive force. Okay, it's always attractive force. You can write that in gravitation, it's always attractive force. Okay, so here like 1 by 4 pi epsilon naught q1 q2 by r square, like this is a constant thing, right now. So what is q1 and q2? It's a charge. So charge can be either positive or negative. Positive, positive, repel, negative, negative, repel, positive, negative, attract. So I can say that electromagnetic force is both attractive and repulsive. Getting the point? When you talk about a gravitational force now, like whatever object you are throwing, obviously it will come towards the earth only. Write down the value of 1 by 4 pi epsilon naught, which is nothing but 9 into 10 power 9. So we will talk about this in detail in the class 12th, okay, like the second year portion we will see. Okay, so when we talk about the charges, it's an electron, no? Electron, no? Yes or no? So like we know that you have studied in chemistry electron, proton and neutrons. Electron is negatively charged, proton is positively charged, and neutron is, it's a neutral thing, it's a zero, right now. And where it presents electron, proton and neutron? Atoms. So if I club atoms together, what I'll get? Molecules. Right now, like I can say it's a matter. Yes or no? So is everything made up of matter? Yes or no? Yes. So can I say like everywhere force is acting? Yes or no? Yes. You are linking the points here. Yes. We are talking about the charges. So obviously like I am talking about a positive or negative charge, whatever it can be, that charges are present in the atoms. When I club together, I can say everything it's a matter, right? No, it's a matter. Tiny particles, no? So everything is a matter. So whatever I talk in surroundings, everything exerts a force. Getting? Yes or no? So under electromagnetic force, we are going to concentrate about a normal force, tension, friction. Okay, these are the things we are going to concentrate. Write down. First point, apart from atomic and molecular phenomenon, the electromagnetic force shows up in many form in daily experience. So are you able to link the points whatever I have told? Getting the points? First one, under this first one, force between two surface in contact, force between two surface in contact. Second one is tension in a rope or a string. So when you talk about the first one, no, two surfaces are in contact. So first surface also made up of a matter, second surface also made up of a matter, a rope or a string. So obviously any material is made up of matter, right now. Third one, force due to spring. String is different, spring is different. Okay. Second one is force due to string or a rope. Okay. Third one is a spring. Spring. So any doubt up to now? Any doubts up to now? Any doubts here? Write on the first one, the normal force. The normal force. Normal force always act perpendicular to the surface. Normal force always act perpendicular to the surface. Okay. So what is the meaning of perpendicular? 90 degree. Okay. So if I take a object like this is the surface and I have kept the object on this. So how the normal force will act? Perpendicular. So perpendicular to the surface. Right now, this is one thing. And if I talk about an inclined plane, so how should be the normal force? Perpendicular to the surface. No, this is my surface, it's perpendicular. Okay. So if I talk about okay, so this is the object and these are the surface. So if I talk about this object, how many normal forces are there? Two normal force. One is perpendicular like this, one more is perpendicular in this direction. Getting the point? Getting the point? So if object is touching the surface and it normal force should be drawn perpendicular to the surface. Okay, perpendicular to the surface. Take the diagrams. So the first one is normal force we have seen. So normal force always act perpendicular to the surface, right now. So when I talk about this is my surface, I am keeping the object on this. Okay. So perpendicular to the surface in the sense the perpendicular should drawn with respect to the surface. And this is an inclined plane. Okay, I kept an object here. So I need to draw the normal force here again. Okay. So perpendicular to the surface I should take it. So again if I see here there are two contact point. Okay, two contact point. So here also I need to draw the like normal forces. So it should be perpendicular to the surface. So this is one surface and this is other surface. Okay. So now if I talk about object on object, so there are two objects like a birthday cake. Okay. So there is a surface. Okay, and object is there. Upon that one more object is there. So how many normal forces will be there here? One or two or three or four, how many? Consider this is my first object. Okay, consider this is my first object. How many surfaces are there for this object? One, two, touching the ground, touching the other surface of the object. Yes, no, surface is not only the ground. Okay, surface is not only the ground. So it should, I should check what are the points it is touching. So one is ground and one is other object. So this one is having two normal forces. What about this one? Only one normal force. Yes or no? Yes or no? Yes, so can I say that if I talk about only the first one, there is one normal force like this. I will name that as N1. Okay. Other normal force will be which direction? Downward direction. Because like for the first one I have drawn the surface, that normal force. Second one if I take, leave about this one. This is my surface, no? So perpendicular to the surface I should take, no? So this will be my normal force N2. Okay. And when I talk about only the upper part, perpendicular to the surface, it is N2 only, because object is not moving, object is at rest. So whatever the force are acting, it should be equal force. Getting the point? Try to understand this and draw it now. What will be the normal forces? So first one, 3 or 4 or 5 or 3. Madam Vijay Lakshmi madam, no? Stand up. Tell, what is this? How? First object any normal force. Second one? 1. Tell. ఎక్కడి సైడ్ నుంచి వస్తుంది? ఎక్కడి నుంచి? ఇటు అంటే ఎట్లా? So for the first one, so one should be towards which direction? So N1. Okay. Other one? N2. So for second one, so one is upward direction N3. So right side N2. It's N2. Whatever the forces are acting, the same force should be there, no? In between them. Yes or no? So one thing you should understand, when the object is at rest, the force between the objects will not be changed. Okay, will not be changed. Whatever the force are exerted on this object will be equals to this object, or this object will be equals to this object. Okay, getting the points? If I change the force, like it will separate, it will get separate. Okay, take. N3 are not equal. N1 and N3 are not equal. It is depends upon the mass of the object. Okay, it depends upon the mass of the object. So just try to understand how to draw the normal force. Still we have not gone into the lesson. Okay, we will see what is the forces and how we should equate that. So now you can able to draw the normal forces. Able to draw? భూమిక మేడం ఇంకా నిద్రలోనే ఉన్నావా ఏంటి? Done. Second one, what is the topic? What is the topic of the second one? Tension. Write down. ಎಲ್ಲ ಕ್ವಶನ್ ಇವಾಗ ನೋಡಿಸಿ. ರೈಟ್ ಡೌನ್. చిన్న పిల్లల. So tension always act away from the body. Always act away from the body. Okay, listen here. Have you heard about this tug of war? Yes, no? Tug of war. Like the two sides of the ropes, people will be there. They will apply the force on each side. So one will be force like this, other force will be like this. They try to pull the force. Yes, no? They try to pull the force. And when I talk about what will be the tension, okay, what will be the tension? What I told? Tension is always away from the body. Force is in this direction. I am applying the force. Tension should be always away from me, which should be in this direction, opposite direction. Opposite direction. For example, if there is a ceiling and there is a rope and object is there, okay, so object will try to pull the rope downward, no? Yes, no? So what will be the tension means? Opposite, just opposite. Getting the point? Getting the point? Suppose if I talk about, I mean this force, it is opposite. Tension, T, T, T. If I talk about a pulley, okay, so for this it will be upward direction. It will try to pull, this also it will try to pull this in this direction. So for this also it is upward direction. Okay, so tension will always act away from the body. Normal force perpendicular to the surface. Okay, just try to understand how to draw it. That's it. Don't analyze or don't do anything more than this. Okay, take it. Okay, right on next point. Same rope, same rope, same tension. Same rope, same tension. Different ropes, different tensions. Different rope, different tension. See, if you talk about this tug of war, no, if I go one step back, what about these people? One step, they will come forward. If I go 10 step back, these people will come 10 step forward. Right, no? So is this the same rope or different rope they are using? Same rope. So same rope, tension will not change here. Okay, same rope, tension will not change. So if a rope changes, tension will changes. Okay, if I mention T here, is this the same rope? Yes. This also T only. If I mention T here, this also T only. The force can be anything. The force can be anything. I am not worried about that force. But same rope means same tension. So any doubts here now? Normal force and the tension. Any doubts? The next one. What is the next one? Spring force. So what is the meaning of spring? Like what we can do by using this spring? Spring. What we can do? We can expand the spring or we can compress the spring, right? No. So initially there will be a length of the spring. I will take this my spring. This is my original length. Original length. If I apply some amount of force, it will try to compress or it will expand. So depends upon my force only, it will expand or it will compress. Yes or no? Any doubts here? Any doubts? So can I say, okay, for expansion we have taken, this is my original length and this is my expansion. Let me take, this is delta x, so this is x. Okay. So can I say force is directly proportional to the expansion or compression? If I apply more force, more expansion or more compression. If I apply less force, less expansion or less compression. So force is directly proportional to the delta x. Any doubt here? So delta x is nothing but either compression or expansion, or you can say that as a change in length. Okay, change in length. And to remove the proportionality, we are adding a constant called k. So k into x. So this is spring force and this is spring constant. Any doubts here? Think do. So what is the unit of spring constant? Unit Newton per meter. Force is Newton and x is meter. So this about the electromagnetic force and the types. Okay. Friction force we will see once we complete this parts. So the third one is a nuclear force, fourth one is a weak force. Okay. So we are going to talk about those two things in the class 12th portions. Okay. And you can take a note point, electromagnetic force greater than a gravitational force greater than nuclear force. Okay, write on the first topic, Newton's first law. Newton's first law. Newton's first law. Write down. So what is Newton's? if an object is at rest will stay in rest and if an object is in motion it will be in, or it stays in motion unless or until an external force act on it Write down the next one, Newton's second law. What is Newton's second law? Only change in momentum? Acceleration. Whatever you have told correct, but some words are missing there. It's a rate of change of momentum. Okay, rate of change of momentum. So rate of change of momentum means it is momentum with respect to time we are talking. We are not saying that it's a change in momentum. Okay, it's a rate of change of momentum. Okay, so write down second one. The rate of change of momentum of a body is directly proportional to the applied force and take place in the direction of the force which we applied. Okay, see, listen. So F is directly proportional to dp by dt. P is nothing but momentum, it is mass into velocity. Which is constant here? Mass is constant or velocity is constant? Why mass is constant? So mass doesn't change, no? Yes or no? If I stay here also, mass will be same for me. If I go somewhere also, mass will be same for me, no? Yes or no? So mass remains constant. I'll take that as m outside dv by dt. What is dv by dt? Acceleration. So m into a. So to remove the proportionality, we are adding a constant k. So the value of k is nothing but 1. So F is equals to ma. Understood? Now so the next law is Newton's third law. If a body if a body A, capital A, if a body A exert force F, if a body A exert force F on another body B, comma, then B exerts a force minus F, okay, force on A, comma, the two force acting along the line joining the bodies. So any doubts here? And the one more force is like it's a gravity, okay, the weight. So the contact forces we have seen, the gravity is not a contact force, yes or no? If there is no contact or with contact, it doesn't matter, but gravity will act, okay, gravity will act. So how it will act? Towards down, okay, towards down. Always gravity acts towards down, gravity, or like we will say it's a weight, okay. So weight is a force. So what is the difference between the weight and the mass? It's a scalar or vector? Which one is scalar? Then what about weight? Why it's a vector? See, you have told the answer now only, how it will act. So downward is a direction or not? Then, so it is having some direction, then obviously it's a vector quantity, no? So weight is a vector quantity and mass is a scalar quantity, okay. So mass doesn't change, okay, it's a like it's a number. So now if I talk about the free body diagram for the weight, so how it will be acting? Towards down. So one thing is, weight is nothing but mass into gravity. Whatever the mass, that mass into gravity, that is weight, okay. Now it is towards down now, this is my weight. If I talk about the inclined plane, how it should be? Now you say how it should be. It will be downwards, okay, it will be downwards. So if I talk about that pulley was there, so there is a block M1 and block M2. So for this is W1 and it is W2. Getting the points? So here if it is M, it should be mg. If this is m, it should be mg. Getting? Understood now? Now after drawing this, important point is there, is weight and normal both are equal? I am drawing a normal here. Here it is equal, n is equals to w, yes or no? Normal is towards up, weight is towards down, so n and w are same, like y direction, no? Yes or no? But when I talk about here, is n and mg are same? No. Then how to find n here? like what is the value of n. Okay, at least you understood, no? It is not same. Okay, sin theta. Okay, draw this. I'll tell you the method to find. Any doubts here for gravity, that is weight? Draw. Listen, see, listen. if you try to understand this, no, it will be easy to take the components of the given things. So this is the inclined plane, no, it will be angle theta, right? No, yes or no? So I told that object is standing like this, and it is my weight, and this is my normal force. So whenever you are having an inclined plane, what you should do is take 8 equal parts. How many parts are there once you check it? 8? 8 parts are there. So if I want to take, can I place this object exactly here? This is my theta. Evakina doubts on the inka? So if I place theta here, leave one, do alternative thetas. So 4 thetas will coming. Now what I told, when theta is close to the axis, that will be cos theta. Yes, no? Can I say this is my cos? Yes. And if I talk about this one, this is my cos, no? Yes or no?
Yes, sir.
Getting the point. What about this one? Sin theta. So can I take exactly here? This is my getting? అర్థమైందా లేదా? Or should I explain once again? So is there any doubt here? Drawing the, like if this is the question, okay, I need to find what is the force which is equals to N, okay. W I know because mass I know, no, like for example 1 kg, so this one will be 10 Newton, no, this is weight, mass into gravity, mass is 1, gravity is 10, so mg 10. I don't know this one. Can I find this one? So graph is there. I am dividing the graph again. Okay. So I am placing the object exactly wherever I want. So this is the object I have placed here. Okay, no? Yes or no? So this is the theta. This is the theta. This is one more theta and this is one more theta. Right now? So axis is this one, like this is my axis now. Let me consider. Okay, I'll take the axis, I place here. This is my normal, this is my weight. Arthamainda? Arthamainda leda? Any doubt here? I am taking the weight to the other side. Taking the weight to the other side. If I take this side or if I take this side, theta right side undi, right side undi kada. Idi cos avutunda, sin avutunda. Each side vaste. So I have taken this is mg sin theta. This is mg cos theta. ఎవరికైనా డౌట్స్ ఉందా? ఇంకెవరికైనా డౌట్స్ ఉందా? సో ఇది అర్థమైంది కదా. సో ఇన్ దిస్ ఐఎమ్ టేకింగ్ అండ్ ప్లేసింగ్ ఎగ్జాక్ట్లీ ఓవర్ హియర్. ఓకే, సో ఐ హ్యావ్ డ్రాన్ ది theta. సో టేక్ ఆల్టర్నేటివ్ thetas. Give one space theta, one space theta, one space theta. First step, whatever the forces are there, try to draw, write that force. Normal force ఇలా యాక్ట్ అవుతుంది కదా, ఇలాగనే యాక్ట్ అవుతున్నాయి కదా. సో ఐఎమ్ డ్రాయింగ్ దిస్ వన్ అండ్ ఎంజీ విల్ బీ టువర్డ్స్ డౌన్, దట్ ఈస్ వెయిట్, రైట్ నో. సో ఈ ఎంజీని నేను మూవ్ చేస్తాను ఇట్లా, ఎయిదర్ లెఫ్ట్ సైడ్ ఆర్ రైట్ సైడ్. సో రైట్ సైడ్ మూవ్ చేస్తే యాంగిల్ ఉంది నాకు. యాంగిల్ ఉంటే ఏం చెప్పినా కాస్ థీటా చెప్పిన. సో ఐఎమ్ మూవింగ్ దిస్ సైడ్, ఇట్ విల్ బికమ్ డబ్ల్యూ కాస్ థీటా, దట్ ఈస్ ఎంజీ కాస్ థీటా. ఇఫ్ ఐ మూవ్ దిస్ సైడ్, ఇట్ విల్ బికమ్ ఎంజీ సైన్ థీటా. ఈ డయాగ్రామ్ ఎగ్జాక్ట్గా ఇట్లా డ్రా చేస్తే ఇట్లా వస్తున్నది కదా. ఇఫ్ ఐ డ్రా దిస్ వన్ like this, am I getting this one? Now can I say n is equals to mg cos theta? Can I say mg cos theta now? Any doubts here? Any doubts? Understood now? So whenever they are giving a inclined plane, try to get the components and try to analyze it. Okay, so don't ever memorize whatever the given terms are there. So take the diagram, split it and equate it. Okay, now which is helping me to go down? Which force? mg sin theta is helping me to go down. Arthamainda? Arthamainda? Take it. So I'll tell one more topic and then I'll stop the class. Equilibrium I'll tell, I'll stop the class and we'll prepare for the exam. Okay. Equilibrium of concurrent CON concurrent force. You used to say concurrent. Okay, the first point. First point, condition for equilibrium. Condition for equilibrium. Okay, first thing I need to get clarified. What is the meaning of equilibrium? Like it will be equal, right? No? Yes or no? Okay, write down. First point. For a body to be in equilibrium, to be in equilibrium, under the action of concurrent force. What is the meaning of concurrent forces? Same. It's like n forces, like n number of forces. Okay. Like F1, F2, F3, F4, like acting on a single object. Okay. So if I talk about the previous cases, normal force was there and weight was there. So two forces were acting on the single object. So I can say that as a concurrent force. Okay. Right on. So for a body to be in equilibrium under the action of concurrent force, for a body to be in equilibrium under the action of concurrent force, the net force, so the net force can be written in terms of summation F. The net force must be equals to 0, must be equals to 0. The net force must be equals to 0. So this is the condition for the equilibrium, first point. Okay. So this summation, like I can say that as F1 plus F2 plus up to Fn should be equals to 0. Okay. Second one is resolution into components. Resolution into components. First one I have written for the condition. Second one is a resolution into components. Now we have talked about the forces. Equilibrium force, that is summation should be equals to 0. Resolution, I have talked about resolution. Meaning of resolution means taking the components in x axis and y axis. So can I say that summation fx will be equals to 0, summation fy will be equals to 0, summation fz also should be equals to 0. Resolution into components. So after taking the components, I should check only the forces are acting in the x direction. Okay, only x direction should be substituted here. Next, vertical, that is y direction. Getting the point? So whatever the forces are acting in y direction, only that force I should consider. Whatever the forces are acting in x direction, only that force should be considered. So the summation should be equals to 0. The condition is equilibrium. If it is in motion, I can't say it's a equilibrium. Okay. If it is in motion means I can say this instead of mass into acceleration. Yes or no? If an object is in motion, obviously object will have some acceleration. Yes or no? If object is at rest means it is 0, so it will be in equilibrium condition. It will be in equilibrium condition. So if I talk about this board, is this in equilibrium condition or not? But forces are acting or not? Yes or no? One is normal force with respect to the surface, one is weight towards down. Both are equal. Yes or no? Both are equal. Can I say that n plus w should be equals to 0, n will be equals to minus w. So one is acting downwards, one is acting upward. The negative symbol gives that the direction of the force, that's it. One is acting downward, one is acting upward, that's it. Getting the point? I have written the summation like whatever the force are acting on the object. Only in which one? Y axis I am talking. Is there any force are acting in x direction? No. No, right? So understood how to write. Any doubts here? Take down. Resolution into components. Done. So these are the points are important to draw the free body diagram. Still we have not started with free body diagram. Okay, just we have drawn what are the forces are acting for different cases. Okay, one more point is there, Lam's theorem. Lam's theorem. LAMIS, Lamis theorem. Lamis theorem, LAMIS. Okay, suppose like we are talking about equilibrium, no, that is concurrent forces. Okay, suppose if I talk about an object is there, there are three forces are acting, or more than three also will keep. Okay, I will talk about three forces, P, Q, R. Okay, P, Q, R. So some angle has been made between them, no. Let me take this as alpha, beta and gamma. Okay, alpha, beta and gamma. So Lamis theorem is nothing but it is used to take the or find the forces, okay, in a concurrent point. Okay, concurrent point. So if I want to find the force for P, P is nothing but P divided by opposite angle whatever it is there, I should write sin beta should be equals to Q divided by what is the opposite angle of Q? Gamma will be equals to R divided by sin alpha. Getting the point here? Whatever the force I am taking, I should write opposite angle. Okay, opposite angle. Only remember the force and the opposite angle. So P by sin beta, Q by sin gamma and R by sin alpha. That's it. So I can consider these two things I can find, or I can consider these two things I can find, or I can consider only these two things I can find. Okay, everything are equal, no? Any two I can take and I can find the things. Any doubts here? Take down. Write down the point under Lamis theorem. It states that if three forces acting it states that if three forces acting at a point are in equilibrium comma each force in proportional to the sine of sine sine of angle between the other two forces, So listen here. So that's what I have told. P by, so P if I talk opposite angle, the other two forces, no. So between other two forces Q and R, if I consider P, Q and R I should consider the angle. If I consider Q, P and R I should consider. If I consider R, P and Q I should consider. So just opposite angle you think, that's it. So any doubts up to now? Any doubts?